channel. My name is Last Mwengi. I'm focusing more on map work skills, especially for FET, grade 10, 11, and 12 geography. So today I'm going to look at what we call grid reference or the coordinates. I'm going to start by simplifying it, explain it in a more simpler way. Then after that, I'll move on to use the map that we usually use when we are doing the grid reference, and also the coordinates, that is our orthophoto and the topographical map. So I'm going to start by trying to simplify it so that it's very easy for each and every person that is going to listen to this video to understand. So when it comes to reference and grid reference and coordinates, the first thing that you need to understand is we that we are actually trying to find the exact location of places on a map, or it can be features on a map. But when we are doing the coordinates, we are looking at the location in terms of latitude and longitude. We are looking at the position of a place or a position of a feature in terms of our latitude and longitude. So the first thing that I'm going to do, I'm going to use the model of our app, which is a globe, or the model of a globe, which is spherical in shape or round in shape. So from this model that we have, we all know that in the center here we have got what we call the equator. And this equator is at 0 degrees latitude. We've got the equator, and this equator is at 0 degrees latitude. Then we also have what we call the Greenwich, the longitude, which is our Greenwich meridian, which is also at 0 degrees longitude. So these are the two lines that we have. We've got the equator, which is at 0 degrees latitude. We also have the Greenwich meridian, which is a line of longitude at 0 degrees Celsius as well. So whenever you are asked to find the location of a place on Earth, it's either north or south of the equator. That is in relation to the latitude. So whenever you are asked to find the location or the coordinates of a place, you find it in relation to either is north or south of the equator. That's why whenever we are doing latitude, we start first with the latitude. Then you're also supposed to find it in relation to its position, the Greenwich meridian, whether it is west or in the eastern hemisphere. So each and every place, if I'm to sum it up, is found in two hemispheres. It's either north or south of the equator, or it's west or east of the Greenwich meridian. That's whenever when we are writing coordinates, let me just demonstrate this one also so that it's easier. I'm going to write 30 degrees north. I'm going to write here 30 degrees south. I'm going to write here 30 degrees west. I'm going to do here 30 degrees east. I'm going to use this just to illustrate in a simpler way, then I'll move on to use the map. So let's say you are asked to find the coordinates of a place at X in terms of its coordinates. So the first thing that you do, you identify it in terms of a latitude. Where is it? North of the equator. Okay, it's at 30 degrees north, which means X is at 30 degrees north. And what is its position in terms of the Greenwich meridian? This is your Greenwich meridian at 0 degrees longitude. You also look at going towards the east, you have it at 30 degrees east. 30 degrees east. So these are the coordinates of place X in relation to its position to the equator, that is at 0 degrees latitude, and in position to the Greenwich meridian, which is at 0 degrees longitude. So whenever you are asked to find the coordinates of a place, you find it in relation to its position to the equator and also its position to the coordinates. The other thing that I want to add on as far as latitude and longitude are concerned is, if you look at in the southern hemisphere, the number increases towards the south. That's why we have got 0 degrees, we have got 30 here, then here we have got 90 degrees south, which is our south pole. Same applies with towards the northern hemisphere, the number increases also towards the north. Here what we have is 90 degrees north, which is our north pole. Okay, then if you can look also in terms of a Greenwich meridian, you can see also that the number increase going towards the east. Same applies here, the number increase going towards the west. So in short, whenever you are asked to find the coordinates or coordinates of a place, you are finding the location, the exact location in terms of the degrees or its position to the equator, of which we say that each and every place that you have in Earth, it exists in two hemispheres, is either north or south of the equator, or west or east of the Greenwich meridian. So I'm going to start off now. You calculate your coordinates using a map. I'm going to draw a map with the latitude and longitude, do all the calculation. Then after that, I'll finish off with the map. Like I've already said, you can see now I've drawn, it's part of my map. I think it's showing the latitude. You can see the latitude, they are horizontal, 28, 20, 21, 22, 23. Then I also have my longitude, which is east, part of the eastern hemisphere. You have got 15 degrees east, 16 degrees east, 17 degrees east, and 18 degrees, which means a place that is part of this map, that is what is shown on this map. It exists in two hemispheres, that is your southern and your eastern hemisphere. That's what this map is all about. So let's assume that I'm asked to find the grid reference. Some call it grid reference, some refer to as coordinates, but it's more or less the same thing. We are used to grid reference as in alphanumeric, like your A2, A3. We'll get to that. Okay, so here, so you are asked to find the coordinates of this X, okay, in terms of latitude and longitude. So what you do, like I've already highlighted, you start off with your latitude, which means X is at, okay? So anything behind 21 is still 20. Anything behind 22, okay, is still what, 21. Anything behind 23 is still 22. Same applies here. Anything behind 16 is still 15. Anything that is behind 17 is still 16. Anything that is behind 18 is still 17. So if I'm to find the coordinates of the location or the coordinates of this symbol that is represented on my map, that is X. So it means I'm going to start with my latitude. Okay, where is X in relation to my latitude? Okay, it's between 21 and 20, which means it's behind 21. So is 20 degrees in which hemisphere? South. I'm also going to find its location in terms of the longitude. Where is my X? It's between 15 and 16 in relation to my longitude, which means it's on 15 degrees east. So this will be the coordinates of X in relation to what the information that is given on the map. I found its latitudinal position in terms of the latitude and its longitudinal position in terms of the longitude. So X is at 20 degrees, what hemisphere, which hemisphere? South, and 15 degrees longitude, hemisphere is, so you have to indicate the degree, the hemisphere in terms of latitude, the degree, and the hemisphere in terms of the longitude as well. So this is how you start by actually writing out your coordinates. I've started off with the degrees, but there is a rule that states that our 1 degree is equivalent to 60 minutes, which means we can actually divide from here up to there. We can actually divide this 1 degree, that is from 20 to 21 is 1 degree, which is equivalent to what we call 60 minutes. I'm writing seconds now, 60 minutes, which means we can divide our grid into minutes as well. Because under coordinates, you can be asked to write your coordinates in terms of the degrees, the minutes, and the seconds. So this is what I'm going to do now. I'm going to write the position or the coordinates of X in terms of degrees and also the minutes. Just do it with me. Okay, so here's how I'm going to do it. On your map, I'm going to give you a rule that you're supposed to use on your map. On your map, if you look at your grid reference, or if you look at your grid from, let's say from here, this 20 up to there, if you look at the length from here up to there, you get 37 millimeters. And if you also look, this is the, in terms of latitude, that is going downward. If you also look at the length from here up to there, in terms of longitude, you get something like 31 millimeters. So I'm going to use this, I'm going to use these two measurements in order to calculate the coordinates in terms of meters. So I have got the degree. Of course, I know that my x is on 20 degrees. I've already said this. My x is on 20 degrees. Of course, it's because it's behind 21. Okay, so what I'm going to do now, in order for me to find the position or the location of x in terms of minutes, I'm going to measure with a ruler from here up to there where my x is. I'm going to measure with a ruler from here where my x is. Okay, I'm going to use my ruler. This is my ruler. Closer. This is my ruler. I'm going to measure from here up to there. I'm going to work with assumptions. Remember, I've said that is 33 millimeters from there up to there. That's the assumption that I'm working with. So I'm going to look at it like, let me say, or let me use what I have here. Okay, so what do I have? If I try to measure the whole grid from here up to there, what do I have? Let me rub off this so that I can deal with the figures that are here on my board. Okay, from here up to there, what do I have? I would say I've got something like 120 millimeters. Okay, then in terms of, I think from here up to there, I'm gonna deal with, that'll be too much. Okay, but I'll deal with it so that for the sake of explanation, so that it is easier, I'm looking at 180 millimeters. So it means in terms of my longitude, here is about 180. You've seen that here is about 120. This is just for illustration. Okay, so what I'm going to do now is I'm going to measure. I have measured from here up to x. What did I get? Okay, from there I got something like 60 millimeters. Okay, over what is the length from here up to there of the whole grid in terms of my latitude. I've got something like 120 over 120 millimeters. Then I'll multiply it by 60 minutes, because I want to know the position of x in relation to the degrees and the minutes as well. Remember, I've said that we can convert, actually we can divide our grid, which is in degrees, into minutes. So what I'm going to do now, I'm going to multiply from here up to there. I've got 60 millimeters. Then from there up to there, I've got 120 millimeters. So it's the shortest distance, as you can see, from where the grid in terms of my latitude starts up to where the feature is, or the location of a feature is, then over or divided by the length of the total grid, which is 120. Then I multiply by 60. Why am I doing this? I want to know the exact position of x in terms of minutes. I already know in terms of degrees, that is 20 degrees, because 20 is behind. Okay, 21 here, so I've got 20. So if I say 60 millimeters, let me get my calculator. I'm gonna calculate. Closer. 60 over 120 multiplied by 60 minutes. I got 30 seconds there. I got 30 minutes, sorry. Over 60, I've got 30 minutes, which means here is what? 30 minutes in which hemisphere south. I'm gonna do the same thing in relation also to my longitude. I'm gonna measure from here up to my x. I have something like, I would say 80. Okay, so I now have 80 millimeters over, remember I said from here up to there I've got something like 180 millimeters. Okay, which is over 180 millimeters multiplied by 60 minutes. I want to find my longitude now. So now it's 80 over 180 multiplied by 60 minutes. What do I get here? I have got 26.6. I'm going to convert it, okay, to the next degree, which is 27. So I will have from here up to there, I've got 15 degrees. Then what do I have? 27 minutes east. So this will be my coordinates. This will be my coordinates showing the degrees and the minutes. So first thing that I did was I showed you the coordinates, how you do the coordinates with only the degrees. Then I even went on to say that our degree can be converted into minutes, into smaller units of minutes, which means that's what I've done now. I've shown you how I do it. Okay, the first thing you need to know, what is the length from here up to there, the whole of the whole grid. I think if I'm to make reference with the information that I have here, I found out that the whole grid going towards the south, which is my latitude, is 120. That is the length of the whole grid going downwards. Okay, I've also done the same thing with my longitude. I've also come up to the conclusion that is about 180 millimeters, which is what I have here. So if I want to find my minutes, okay, find the location of X, what I've done is I have marked from where the grid starts up to where X is. This is how I got this 60 millimeters. I've also marked the length of the whole grid. This is how I got the 120, that is here. Then I want to change, or I want the exact location in terms of degrees and minutes. So what I'll do is the shortest over the longest multiplied by 60, because I want to convert this into what? Into minutes. That's why I multiplied with 60 minutes, as you can see there. So from there, I've got my latitude 20 degrees, which is this. Then I've got now my location in terms of minutes, which is 30 minutes, because I've said 60 over 120 multiplied by 60 minutes. That's how I got the 30 minutes here. That's how I got them. 30 minutes, that is here. So I've got my degree, I've got my minutes. In terms of my longitude, I've done the same thing as well. I've measured from here up to where X is. I've got 80 millimeters. This is where I got these 80 millimeters. I also measured the whole grid towards going towards the east, where it ends from here up to there. I've got something like 180 millimeters. That's where I got it. Then I want to convert it into minutes. That's why I multiplied by 60. So 8 millimeters over 180 millimeters multiplied by 6 minutes. That's how I got first the 15 degrees. Then after that, I got the minutes, then the hemisphere. So this is how you do your coordinates when you are writing the location of a place or a feature on a map in relation to the latitude and longitude. The first thing I've done, calculate the degrees, in terms of degrees. Then I went on to add on the minutes. So the next thing that I'm going to do now, I'm going to calculate now using the seconds. I'm going to calculate using the what? The seconds. Why am I doing that? Because the first two I've said 1 degree is equivalent to 60 minutes. Then 1 minute is also equivalent to what? 60 seconds. So I'm going to find the exact location of C as it is, but I'm going to find it in relation to the seconds. So what I'm going to do, the first thing that I'm going to do first is I'm going to change this. I'm going to change this, okay? I'm going to write this. That's what you normally find in your map. That is 20 degrees. Let me say 20 degrees, 30 minutes. That is south. 20 degrees, 31 minutes. Then 20 degrees, 32 minutes. Then 20 degrees, 33 minutes. Okay. I'm going to do the same thing here. 15 degrees. 15 degrees, let me say 30 minutes. This one also 15 degrees and 31 minutes. Then 15 degrees and 32 minutes. Then 15 degrees 33 minutes. So I'm going to use this now. The assumption is we already have these figures. We already have these figures, okay, that are written here. Okay, let me rub off these. Let me rub off this as well. So what we want to do now is, usually your map, you are given the coordinates on the map. This is your latitude, 20 degrees, 30 minutes, 20 degrees, 31 minutes, 20 degrees, 32 minutes, 20 degrees, 33 minutes, which means it's within the same grid. The only thing that is making this different is in the minutes, because here is 31. You can see the number of the latitude is increasing towards the south, but it's increasing in terms of minutes now. It's still the same degree, but different minutes. 20 degrees, 30 minutes, 20 degrees, 31 minutes, 20 degrees, 32 minutes, and 20 degrees, 33 minutes. Same applies with your latitude. 15 degrees, 30 minutes, 15 degrees 31 minutes, 15 degrees 32, and 50 degrees 33 minutes. So if you are asked again to find the coordinates of x, okay, in terms of your degrees, minutes, and seconds, so wherever you are asked to find or write all the coordinates as degrees, minutes, and seconds, on your map you'll be given the degrees and also the minute. So the only thing that you have to calculate is the seconds. So still our rule applies. 1 degree is equivalent to 60 minutes and 1 minute is equivalent to 60 seconds. This is how you write your seconds. This is how you write your minutes. Make sure that you use these symbols. Okay. So for my x now is equal to, let me write the information that I have here in the first place. Okay. So what do I have as coordinates of x in terms of degrees and minutes? Already from what is given on the map, this 30 minutes is behind 31, which means from here up to there, it still falls under 20 degrees 30 minutes. So my x now in terms of degree is 20 degrees 30 minutes. That is shown. The only thing that I have to calculate is my minutes. How do I calculate my seconds? Sorry. So I will do the same thing that I have illustrated before. So I will measure from here up to there. What did I get? Remember from my previous example, all right, let me just shift it a bit. From my previous example, I got 60. You can see from here, okay, okay, from here up to there, you can see I've got something like, let me use the millimeters, okay? From here up to there, I've somewhere at 60 millimeters. So I'm going to use the same thing, 60 millimeters over what is the length of the whole grid from there up to there towards the south. It's 120 millimeters. Then I'll multiply it now by 60 seconds because I want to know the location in terms of second. I already have the minute, the degrees, and the minutes. I want to find the second. So what I'll do is 60 millimeters over 120 millimeters multiplied by 60 seconds. Okay, let me see what I'm going to get there. So I'll use my calculator. 60 divided by 120 multiplied by 60 seconds. What is going to be is 30 seconds. So it means my answer will be 20 degrees, 30 minutes, 30 seconds. Which hemisphere? South. Remember, south, south, going downwards, okay? This is my coordinates in relation to the latitude. Then the longitude, I'm going to do the same thing, okay? This is where my x is, okay? I'm going to find out, okay? From here up to there, you can see it's at 80 millimeters. Then from here up to there, I've got 180, remember from the previous example. Then I multiplied by 60 seconds. Okay, I'm going to do the same thing. That is my 80 divided by 180 multiplied by 60 seconds. What is my answer? Ta-da! 26.7, which is more like 27 seconds. Okay, so I'm going to check my answer now. It's 15 here, degrees. How many seconds? 31. Okay, 13 and 27 seconds. What is? So this is my coordinates. This is how I come up with my coordinates for x in relation to the latitude and also the longitude. Okay, so just to sum it up. So when you are looking at this now, we are saying now, whenever you are dealing with coordinates, you have to know that each and every place that exists on Earth, it exists in two hemispheres. That is either north or south of the equator or west or east of the Greenwich Meridian. But from the maps that we use mostly in Southern Africa, obviously, in terms of the equator is Southern Hemisphere, and in terms of the Greenwich Meridian is Eastern Hemisphere, depending with the location. I'm not talking about South America, I'm talking about mostly South Africa, I'm talking mostly about Zimbabwe. Obviously, you know that it's in the Southern and Eastern Hemisphere. That's why we use these two hemispheres when we are writing our answers. So what we are saying now is, this is what is usually shown on your maps. You have got your degrees and your minutes. The only thing when you're calculating coordinates, you will have to calculate only the seconds, and I've done the calculations of how you can do it. You can have also another question that asks you to calculate. I'm going to demonstrate now. You are given the coordinates like the way they are. These are the coordinates. Then they ask you what is the feature that is found where these coordinates are. Okay, you are given the whole coordinates like the way it is now. Okay, you have got these. Then you are asked what feature or which place is located on these coordinates. So if you are given this and you don't have the feature, this is another way that you can actually do to find out the feature that is represented by this coordinate. So what you do now is you are already given your minutes. Okay, so it means I'm going to deal with my seconds in order to find out. I'm going to deal with my seconds in order to find out the location or what feature is located in these coordinates. So what I'm going to do already, I know my 20 and 30 minutes is on the map. I know my 15 and 30 minutes is on the map. So I want to find out now, given the coordinates, I want to find what feature is on this given location. So what I'll do is I'll use my minutes, okay, my seconds. I'll go to find the latitudinal position. I'll go and take out my seconds. I've got 30 seconds here. Then I'll say over 60 seconds. Then I'll multiply by the length of the grid going southwards. Okay, from here where my latitude starts up to where it ends, I'm going to measure. Remember, I already have 120. So I'll multiply now by 120 millimeters. Okay, that's what I do now. So I'll say my seconds in terms of my latitude, which is 30 over 60 seconds multiplied by the length of this latitude going downwards. That is 120 millimeters. What am I going to get? I get 60, which means here I'm going to get what? 60 millimeters. So for me now to know in terms of my latitude what features on there, I'll then go to my map. Then I'll measure from here up to there. Where do I have my 60 millimeters? Okay, in terms of latitude, here I've got X, okay? I'm going to do it as well in relation to my longitude as well, okay? So to my longitude now, what I'm going to do, I'll take my seconds, which is 27. So I'll say 27 over what is the length of my grid in relation to the longitude, 180. Okay. So I'll say 27 seconds over 60 seconds multiplied by 180 millimeters. Okay, that's what I'm going to do, which is 27 over 60 multiplied by 180. What do I get? I'm going to get something like 81 millimeters. Okay, which is equal to 81 millimeters. So I'm going to take my ruler as well. I'll check from here up to there. Okay, I still have X. So it means the feature that is at this given coordinates is X. I've shown you how you can do the coordinates for X and also how you can come up to know what feature is on this location, that is in terms of your coordinates. This is how you do it. It's very easy. So in short, I'm saying whenever you are doing coordinates, you should be able to actually calculate the coordinates of a place, especially when I give an map, because it has got minutes and degrees and minutes. The only thing you have to do is to calculate your seconds. I just want now to demonstrate using a map. Okay. Let's using a map now. Come closer. I want to make sure that this comes out clearly. I'm going to demonstrate now using a map. So this is what I've been saying. The reason why I started with those diagrams that I was demonstrating with, I wanted to simplify everything. So this is the map that you'll be dealing with. This is your topographical map and this is your orthophoto map. But mostly I'm going to work with the topographical map. So remember I was talking about the latitude. This is the latitude, 28 degrees 31 minutes south. So if you check here, 28 degrees 31 minutes south, then you can check at the bottom, there is 28 degrees 36 minutes south. So they don't write going downwards, but you know now that the degree is still the same. That's why it's 28 here and 28 here. But the only thing that is changing is the minutes. I'm going to count from the top. You can see there is 31, here is 32 where the grid ends, 33, 34, 35, 36. So they just write here at the top 28 degrees 31 minutes south and 28 degrees 36 minutes south. So the whole of this is still in the same degree. Remember our rule, our degree, which is 28, have been divided into minutes. Okay, 60 minutes, then 1 minute equivalent to 60 seconds. We are still using the same rule. So that is it in terms of your latitude. So from 28, 31 minutes to 28, 36 minutes, that is your latitude. The numbers in terms of minutes are increasing, going towards the south because it's in the southern hemisphere, okay? Then if you can check also here, you can see that this is our longitude is starting at 29 degrees 45 minutes east, and it increases going towards the eastward, which is here we still have the same degree 29, then we have got 50, which means if I'm to count, there is 46, 47, 48, 49, 50. So what I was saying the time when I was illustrating those diagrams, I was saying that if we are to look at our latitude from 28 degrees 31 minutes, which means here we have got 28, it's still 28, but it's now 32, which means anything that is on this grid in relation to our latitude, it still remains 28 degrees 31 minutes south. 28 degrees 31 minutes south, because it's behind 32 minutes, the degree is still the same. If I'm to go to the next one, which means this is 32, this is 33, anything on this is 32, then I go to 33, which means 34, anything on this is 33, so it increases going towards the south. Same applies with my longitude, it's increasing going towards the east. I'm going to calculate one feature, okay, that is on my topographical map. I'm going to do the coordinates for that feature. I'm going to pick one there. I'm going to pick the spot height, that is spot height, this one, 1159. Spot height 1159. I'm going to write the coordinates of that spot height, degrees, minutes, and seconds. Remember, on this map, like I've already highlighted, is shown in degrees and minutes. So, which means the only thing that I'm going to calculate is the minutes. So, if I look at 1151 in block A1, okay, that is more like a grid reference as well, A1. So, I'm going to take the latitude of 28. You can see at the top, that is 28 degrees. What is the minutes? 31 minutes. I'm not going to write the hemisphere because I want to calculate the seconds first. So I'm going to use my ruler from here. Okay, you can see from here up to where my spot height is around 10 millimeters. So I'm going to use them 10 millimeters. Remember the rule that if you measure from here up to there, okay, from here up to there, on all the maps that we use in South Africa, you would find that the length from here up to there, it's 37 millimeters. I've also measured, I think you can see it's 37 millimeters. So I'm going to use the shortest distance from where my grid starts up to where the spot height is 10 millimeters multiplied by 37 multiplied by 60 seconds, because I want to change this into seconds. So I'll have an answer like 10 divided by 37 multiplied by 60 seconds. What do I get? I'm going to get 16 seconds, 16.2. So it means here it's 16 seconds, hemisphere is south. Okay, I'm going to do the same thing in relation to my longitude. From here up to there, what do I get? Millimeters. I'm going to get something like, I would say, it's 8 millimeters. So I've got 8 millimeters. You should also know that because we use the same map, from here up to there, you have something like 31, 32, or 33. Let's say, I'll deal with 32. Let me say 32. So I'll have 32 millimeters. Then I multiply by 60 seconds because I want to convert that into seconds. So I've got 8 over 33 multiplied by 60 seconds. Then what do I get? I've got 14.5. I'll just convert it. The next number, okay, that will be 15. So I'll have 15 there, okay, which is equal to 15 what? Seconds. So let me check my longitude. Here I've got 29, okay, degrees, then 45 minutes and 15 seconds east. So this is how you do it. These are the coordinates of spot height, okay, 1159, which is in block A1. This is how you do your coordinates. This is how you do your coordinates. I think I also demonstrated they can ask you, they can give you these coordinates. Let me just do this. They can give you these coordinates. And they don't tell you that it's spot at 159, which is in block A1. They don't tell you that. They can give you these coordinates and say, find the feature that is represented by these coordinates. How do you do it? Okay, so the first thing, like I've already demonstrated, you work with your seconds. You work with your seconds. You work with your what? With your seconds. Why are we saying that? Because on the map, you are already given the degrees and the minutes. The only thing that you need to know so that you can find the exact feature on this location is your seconds. That's what you're supposed to use, because your map shows the degrees and the minutes. So what you're going to do is you're going to take your second. I want to find the latitudinal position. I'll say 16 over 60 seconds multiplied by, okay, what is the length of my grid square? Okay, from here, in terms of my latitude, I've already talked about this, it's 37, which means I'll multiply it by 37 what? Millimeters. Okay, so I'm going to say now 16 over 60, these are the seconds, multiplied by 37. Why do I get here? I've got 9.8, which is more like 10, which means I'm going to get here 10 millimeters. So it means if I'm going to check now in terms of my latitude, I'm going to measure from here up to there. I want to find out where is my 10 millimeters. You can see 10 millimeters from there up to there is getting me to the spot at 1159. I'm going to calculate also in terms of my longitude. I'll take the seconds, which is 15 over 60 seconds multiplied by what is my length in relation to the longitude. From there up to there I've got 33, so I'll multiply it by 33 millimeters. So now I'm saying 15 seconds divided by 60 seconds multiplied by 33. What do I get here? I've got 8.25, which means my answer here is 8 millimeters. That's how I got it. So you can be asked to find the coordinates of a place. Given the coordinates, then you are supposed to do the calculation to determine which feature or what feature is at the given coordinates. And also you can be asked to calculate the coordinates of a place in relation to the degrees, minutes, and seconds, of which you are not given the degrees and the minutes. The only thing that you are given is the seconds. So this is how you do it. It's very easy to do these coordinates. Please go through this video and you see how I have simplified. This is how you do your coordinates. This is how you do your grid reference. Ta-da!